continue straight from previous video where we have obtained the cardinal direction beta versus side wind speed, and we plotted the various velocity with the directions. Now we are now going to draw these lines, which is a theta value. Now that theta is the one that we have given in the question, so that is a theta 15 degree. So this line from the north is a 15 degree. Now that also I can explain it in our diagram, where I have taken this diagram where this line is a 15 degree from the east. So we're taking this on this side, so that is let's say minus 15. So we are going to plot this north on the left side of 15 degrees. So if I draw this solid line, let's say I draw the solid line which is theta 15 degree. Let me use this red pen here, which is from the east. We are going to put this line which is theta value, and that theta is 15 degrees. So if I'm putting it here, we can say that this distance is nothing but 15 degree, right? You agree with me? That's right, that's 15 degree, and that's nothing but I draw this line theta line from the Australian standard figure 3.2.3. Now I'm interested in drawing this line, which is plus and minus 45 degree from this theta line, which is actually your sector of plus and minus 45 degree. So that's let me draw this plus and minus 15 degree one, which we can draw it here. So this is 45 different, so that is from here to here is 30, and another one which is from almost let me draw here, which is almost here, and this one 50. So we need to draw 30 here. Let's draw it up here, and that will give us this 45 degree here. So let's put this one here, put this one here. Now this one is 45 degree, and this one here 45 degree. And if you want to say this is 30 degree, this is 15, and this is 30 degree, right? So that's, I just draw it I draw it here, this two dotted line 15 degree. Now we are interested, now look at this one. Now we have two options. We can calculate the velocity at here and velocity here based on the interpolations, and we can find the maximum value. But by looking the figure, we can say that this point is it has a higher velocity here. You can see this one is 33.1. if I interpolate this one here, I can get 33.1 here, but I should get some value between 33.1 and 35.2 at here. So that is basically higher than 33.1. so we can say that this is our velocity for the case of that line. Now to do the calculation for this case, I am going to draw let's say just a magnified view of this one. Let me draw north and east. So I'm just drawing this line, because I need to get the interpolation here. So let me draw here, that is north, which is here. Let me put this one northeast, that is here, and let me put this 35.2 here, and draw the line here which is 33.1. Actually I draw this line here, this one here, and I'm going to draw this blue line. Let me draw this blue line where I like to find the velocity x, and that blue line is located, I think 15 degree. You can see that is 45 degree, and if I have 15 degree here, so that is 30 and that is 15. So that will give us this difference here is a 15 degree. This total is 45 degree, right? So I think we can do the interpolation quite easily. You can see here we have 15 degree here. That side draw, that is from here to here, which is 15 degree, and from this northeast to east, northeast to north is 45 degree. We are interested in finding this one. Now in this case, if I do the interpolation here, I can say that this is 45. Let's put the whole 45 here, divided by this 15, equal to, and this same concept we're gonna do it, this one whole thing, which is this one. Let's put this big one first, so 35.2 take away 33.1. So this 45 respectively this one. Now this 15 which is here, so that would have a this one x take away 33.1. so it's quite simple here. Take 45 first, so that is 45 respectively. You need to take this big one 35.2 take away 33.1, and this 15 which is here respectively we take this difference x take away 33.1. now if I simplify this one give us 3 equal to 35.2 take away 33.1 x take away 33.1. so x take away 33.1 is equal to 35.2 take away 33.1 over 3, and that's give us x 35.2 take away 33.13 plus 33.1. now this value give us x is equal to 33.8 meter per second. So if I draw the building here which has a 15-degree orientation given in the examples, so that's 15 degree here, this direction we found which is 33.8 meter per second, right? So that's the first one that we found it here. Look at here, different, we have this one 33.8 and here 33.1. so between these two we are taking the maximum value 33 point, so that is a sector plus and minus 45, and we are taking 33.8 meter per second. That's for this first orthogonal direction. So we just calculated from the Australian standard. If I can show it here, this is the building orthogonal directions. We calculated this at theta equal to 0. It is 33.8 meter per second. In the next video we are continue calculating in the other three orthogonal direction. Thank you very much.